Hi, welcome to another mini lecture on precalculus. Today's topic, again a short one, converting between logarithmic and exponential equations. So what you see here is that an equation is written. This is the so-called exponential format. We want to change it to the logarithmic format. So we want to rewrite this thing in a logarithmic way. This is the opposite. An equation is written in a logarithmic way, and the question is how is it to be written in an exponential format. Let's just remind ourselves of what the basic issue is. If you have b to power of a is equal to some number c, that is same as saying that logarithm of number c in base b is the number a, and vice versa. If you have this logarithmic format, you can get this exponential format. So this is called exponential. For obvious reason, we see the exponent right off the bat, and this is logarithmic. So if you have 4 to power of 3 is equal to 64, the objective is how do we rewrite this thing so that we extract this exponent. And here is the way to write this. Logarithm of 64 in base 4 is equal to 3. So when we write this equation in this way, means this base raised to that exponent is going to give us that number back. The opposite of this thing is, for example, logarithm of 1/6 in base 6 is equal to -1. What does that mean? Another way of writing this in is that this 6, so let me color it that you see what 6 is meant. This 6 raised to the power of -1. So who's -1? Of course, this is the -1 is equal to, of course, 1/6. So this is our 1/6 here is the result of this calculation. So the idea of going back and forth between the logarithmic and exponential format is as you see it here. Now it doesn't matter how complicated the expressions might be. Here all the examples are just numbers, but if you had something more complicated looking, the idea is the same. So if you had, for example, logarithm of say x squared plus 1 in base let's say q plus 2 is equal to say a plus 3, strange looking thing to write. All this means same as before, it's just that whatever you had as the base, this is your base, so raised to the exponent, so this is the base. We don't care about what is, we don't get distracted by what is inside these boxes. So here I write my base, here I write my exponent, and here I write my result, which is x squared plus 1, and that x squared plus 1 is what this. So sometimes you kind of have to do the substitution in your mind, not to get sidetracked by the details of the expression. The idea is all the same. So this equivalent to this one. Okay, that's all there is for this lecture. Until next time, good luck and God bless.